All right, so I'm going to take you through the rest of lesson 7. We previously worked through puzzles 2 through 9 together, so if you missed any of those, you can refer to the previous recordings. Today we're going to look at puzzles 10 and 11, which are the last programming puzzles, and then we're going to look at the check for understanding. But I would really recommend trying the check for understanding on your own first before continuing to that part of the video. Because it doesn't matter if you get it right or wrong, I just want you to practice thinking about these questions because that's what's going to be most useful for you. Okay, so number 10 basically uses the flowchart that we looked at in a previous lesson. Can I adopt a cat? And so we're basically going to be using that logic to build this application that can tell us whether or not you can adopt a cat. So if you remember from the flowchart in, I think it was lesson 6, um, in order to adopt a cat, we actually need exactly $40, and we have to be um, over the age of 14. Okay, so if that's true, we can adopt a cat, and if it's false, we cannot. So in this application, we want to actually ask the user for their age and how much money they have. And in order to do that, we are going to use a special function that is in our library. It'll be, I believe, under the yellow section. We want to use this one, get number. And we want to use get number because what get number is going to do is it's going to store the user's input as a number, which will enable us to use these inequalities here to see if money is exactly equal to the number value 40 and if the age number value is greater than 14. If we use get text, it's actually going to store that value as a string, and so these inequalities will not work the way that we want them to. So we have to remember to use get number. The other thing we need to do is once we get those values of age and money from the user, we need to write this inequality in a conditional, an if block. And so we're going to write that Boolean expression inside of the if, and we do need to use a logical operator. We're not going to use all of them. If we look at the diamond here, we can see that we're going to be using the and. Okay, now in this puzzle, you cannot go into block mode because we have some errors here. So if you're trying to get into block mode and it's not working, don't panic. It's not going to be able to go into block mode. There's nothing wrong with your code.org. We do have a reminder that we can find the ID of a screen element by hovering over it with our mouse. And that we're going to need that in order to get the number from this field, age number, to be able to store a value into our age variable. And we're also going to have to get a number from money number to assign a value to our money variable. Okay, so let's take a closer look at the code. You'll notice right away that we have some warnings here on the first 2 lines. And these warnings are nothing serious. They're just telling us, you have these variables and they even have a value of 0, but you're actually not using it in the code. And so it's not affecting the behavior of your program. So that's just warning us that, hey, you could delete these lines and this program will work the exact same because it's not being used anywhere. But we don't want to delete those 2 lines. We actually want to use these 2 variables in the logic for a program. So that's one of the steps we're going to take. So the first thing we notice is that these 2, age and money, have a value of 0. So I could write that like in our flowchart. But these are actually just dummy placeholder values. We're not going to have a person that's 0 who has $0 trying to adopt a cat. Maybe, I don't know, but not likely. A lot of times programmers will put in these dummy type values just to make sure that the variables are initialized in the beginning, but with the understanding that, you're going to change these to real values later. So that's what we're going to start with. Now, if you look at a little bit lower here, you'll notice that after we declare those variables, the remaining code is actually just an event handler. So all of this code that's inside of this event handler, so from here to here, is only going to run when this event takes place, when we click the adopt button. So the first thing we see happen is that two elements get hidden, and that's these two pictures right here, yes cat and no cat. That's because when we first start, we don't know the result yet. Um, the result is uh, basically going to be, we're going to see one of these two pictures. So if we can adopt a cat, we're going to see yes cat. If we can't, we're going to see no cat. Okay. But in order to figure out which one, which decision, we need to know how old is the person and how much money they have. And for that, we're going to use this get number function. So if we look at the get number function, we can see that you can call it, but on the inside, we need to tell it the ID of the element to get the number from. So we're first going to get a number that's going to be the person's age. So since we already have that age variable here, all we have to say is age gets, right? We're not going to put var before it first because we only put that when we're first creating the variable. It's already created for us, but now we're going to update the value. So we're going to say age is now going to get the value that's inside of age. So we need to say get the number. We're going to get the number value, get number. And then inside, oh my goodness, we're going to put the name of this element, which is age number. If you want to be lazy like me, you could see that there's a list of the elements here. We could just click that and it'll put it inside quotes for us. Remember that the element names, the element IDs are strings. So make sure that there's quotes around that name. Okay, so in that step, we basically, got the number. So I'm going to say get the value of age and assign it to the variable age. Cool, so we did that. Now we want to do the same thing, but for money. So we want to get the value of money and assign it to the variable money. So I guess I should say the value of money number, because that's what the element ID is, and same with this one. So this is the value of age number. Okay, cool. So basically we're going to do the same thing as up here, but just change the variable name and the element ID. So we're going to use the variable money. Money is now going to get the number from, my goodness, from money number, right? So we can go down here and select money number. Don't forget your semicolon. Okay, so now whatever the user inputs in these two fields, let's say that the person put in that they are 16, and that they have maybe $40. That means that on our flowchart here, those values would be stored inside of those variables, so 16 and 40. Okay, and we'll see example runs as soon as we take care of these errors. We can't run our program yet because we do have those errors. So let's see what's up with that. These errors are here because we don't have a conditional inside of this if. That's actually one of the steps that we need to take. We need to write the Boolean expression, so the same Boolean expression right here, inside of the if statement. So we can actually just copy it verbatim, word for word from here, because this is actually JavaScript syntax. So we're going to check to see, is money exactly equal to 40? We need to have exactly $40. And if our age is greater than 14. And right away we see those errors disappear because really it was just this missing if. It couldn't do these other things without that if there. That's why we had all the errors go away at once. I know some of you like to maybe have this a little more organized. So maybe grouping the left-hand side, that conditional, and then grouping the right-hand side. Totally optional to do that, but it is a little bit more visually easier to kind of read and visualize what's actually being done in that conditional. Okay, so now with our errors gone, we can actually test this out. So let's actually use these two values to check to see if our program works correctly. So if we have an age of 16 that is greater than 14, so that's true. And if we have exactly $40, this left-hand side is going to be true. So we're going to expect to see the yes cat. So let's go ahead and run that. And I'm going to go ahead and clear these annotations. So 16, oops, get my mouse, there you go, 16 and 40. So I'm expecting to see yes cat when I click on this button. Yes. Now, if any side of this expression is false, the whole thing's going to be false. So if I have any other money value other than 40, like for example, even something that's bigger than 40, I should see no cat. Same thing if it's like less than 30. Let's say I have $3, also no cat. Now, if I have the exact money amount, but my age is not within this range, say that maybe I'm 10, I'm also going to have no cat. But if I'm older than that, if I'm older than 14, let's say I'm like 20, I can get a cat. Awesome. So if you have any, syntax errors or anything like that, go through the video again, make sure you didn't miss any step. Look out for mismatch parentheses is a big one, or missing a semicolon, or even missing your quotes around your element IDs could be a potential error. Okay, so at this point, if you're done, make sure you hit that finish button. And then in the next exercise, we are actually going to change the behavior of this application just a bit. So right now, the behavior of the application is such that you're able to adopt a cat if you only have exactly $40 and you're the correct age. But that doesn't make a whole lot of sense, right? Usually if you have, the amount or more, you'd be able to adopt the cat. So that's the first thing we're going to change. We're going to change it so that you can adopt the cat if you have $40 or more. So take a moment. You might want to pause at this point and think about what you would want to change in the code in order to make this happen. But I can see that I'm probably going to want to change this part of the code right here, the part that actually says you need exactly $40. And instead of using the equals operator, I want to use the greater than or equals to, because that's going to allow me to, have 40, 41, anything that's bigger than 40, in addition to the number 40, and this will be true. So like I can have $50 and be over the age of 14, and I can still adopt a cat. So let's go ahead and test that. Let's say, I'm old enough, and now instead of having exactly $40, let's say I have, I don't know, $50. I should be able to adopt a cat. Cool, it says yes. So that works out well. Now this next one might be a little bit more of a thinker. So the other change we have to make is that now this application is going to acknowledge Teenager Day. So it's Teenager Day at the animal shelter, and when this happens, only teenagers are allowed to adopt cats. So we're going to update the code to prevent anyone under the age of 13 or over the age of 19 from adopting a cat. So first of all, we can see that the lower number, right? Originally, you had to be over the age of 14, but now you can be 13 or older, right? So we could actually change this age is greater than 14 to, we could say age is greater than 12. That would indicate that you are 13 or older. Or you could even say if age is greater than or equal to 13. That works as well. I like that one because you can see the actual value that is in the problem statement. But it's not just that you're 13 or older, but you also can be any teenage age. So that's 13 through 19. So you can't actually be over the age of 19. So what the heck does that mean? That means that I need to add another and here with another statement that includes age. And in this statement, I'm going to check to see that my age is um, less than, I could say less than 20, for instance. Or if I wanted to include the value that's actually in the problem statement, I could just say less than or equal to 19. So that means um, I can only adopt a cat if I'm between the ages 13 and 19, and I have $40 or more. So this one was a little bit more difficult to think about because you had to realize that, hey, I need to put in yet another condition statement. And notice that you can have more than one and in a compound Boolean expression. You can add on as many as you want. Um, we just haven't really seen examples of that. And on the AP test, I don't think you'll see very many, if any, examples of compound expressions that have multiple logical operators like this. If you choose to go on to, say, AP Computer Science A, you will see more complex statements like this. But let's go ahead and test this out. They have some test values for us to see if we've done this correctly. So let's go ahead and reset this. So let's try 18, which is a teenaged year, and 40, which is a valid money amount. So we should see you can adopt a cat. And then let's try 18 and 50, which should also be valid. If we choose 12, that's an invalid age. So we should see no. And then 13 is a valid, 13. And 13 is valid, but the money amount of 39 is not. So we should see no. And then let's do the age of 20, which is an invalid age, and a money amount of 100, which is valid, but that's going to be false because of the age. So again, no. So that works out well. And again, if you missed any step, feel free to, rewatch the video and watch out for, mismatch parentheses. Make sure that you have two logical ands here. And yeah, I think that's probably going to be the source of most syntax errors for this one, since really the only thing we modified was line 16, was the conditional statement. Okay, so at this point you can go ahead and press finish. And the next question is actually an AP test practice question, a check for understanding. So at this point, I, again, I recommend pausing the video and trying these out on your own. Think through it, write down on scrap paper, because that's going to be helpful to, trace through the code, and then you can kind of watch the rest of the video. All right, so it's actually showing the answer because I went through this and I guess I didn't record myself, but pretend you don't see the answer. So on the AP test, you are going to be given the same AP reference sheet. So don't worry about memorizing any of this stuff. You're going to be given this to refer to. But basically what this is a reference to the pseudocode format that they are using on the AP test. So in our class, we're learning JavaScript, which has a specific syntax, but the AP CSP class is not, it doesn't mandate any specific programming language. And for that reason, on the multiple choice test, they use pseudocode, which is, a fake coding syntax that all people are going to be familiar with. And so to remind yourself of that syntax, they give you this reference sheet. So you'll notice, for example, in JavaScript, we don't use these symbols, like not equal to has like the exclamation mark, but these are still familiar to you from like math textbooks, so that's cool. And then your logical operators, instead of having like the exclamation mark for not, it's just going to be in plain English and capitalized. Same for or and. You can see those there. Conditions are going to be kind of like in an oval like that. And then a block of statements that are inside of, like, say, a condition statement will be in kind of like a square. And they'll kind of try to use coloration so that you can kind of see, this is the if with the condition, and these are the statements that execute if the if is true. So, yeah, you'll be given this reference sheet, and it's always good to practice with, the same format of pseudocode as you'll see on the AP exam. And so throughout code.org lessons, they'll give you different opportunities to see those things. So let's look at this practice question. Okay, so in this practice question, you'll notice that there are two variables that get assigned values. So if we kind of like use our plastic baggie model, we can kind of represent that. So we have a variable called score, and inside of score, that has the number 4 inside. And then we also have another variable called lives, and that is storing the number 3. Cool, so that's our memory model. And now we can look at, this is a conditional block, right? We've got our if and we've got our else. And notice that inside of this else, we have what's called a nested if, so another layer of conditional. All right, so if we look at the first if, it says lives is equivalent to 0. So notice that they use a single equal symbol here. This actually is the same thing as the double equal sign for them, because they use this left hand facing arrow for assignment. Okay, so that's one difference that you need to kind of see there. So this is asking, is lives equal to 0? We know that lives is actually 3, so this is going to be false. And if this is false, that means we are not going to go and execute this statement. Instead, we are going to go to the else. And so inside the else, again, we see this other condition block. So now we have to evaluate this if. So we have to check, is score greater than or equal to 5? Score is 4, which is not greater than or equal to 5. We see an and here. And we know for an and statement to be true, both sides have to be true. I already know my left-hand side is false, so I can do what is called short circuit evaluation, which means I don't even bother looking at the right-hand side because I already know that it's impossible for this statement to be true because already I have a false on this side. So that means I'm not gonna do this either. Instead, I'm going to go to the other else. And what gets printed out is you win. So if I scroll down, I can see the answer. I only see this because I'm a teacher, right? You're not going to see the answer down here. But hopefully um, you arrived at the same decision. And if not, hopefully this explanation kind of made it clear why you win would be the answer. So I'm going to go ahead and submit that one. And let's look at this next one. So in this one, if I scroll down a bit, here's our practice question. And in this question, it says that the program below asks a user to type in a number. And so we see here this input. This means that the user is going to provide a value. So user's value is what I'm going to put here. And based on that user input, we're going to see some sort of message be output. What we need to figure out is what number will a user need to input for the message cold to display. Okay, there's actually several numbers that they could put, but which number from the options above? Okay, so let's take a look at, let me realign this, there we go. So we want the message cold to be displayed. So that means we want to wind up right here. This is the only case in which we will see the message cold appear. So one thing that I think is going to be helpful is to kind of mark this up a little bit. I can see that inside of this if, there's a nested conditional, right? So I'm going to go ahead and just kind of mark this up a bit to make this a little easier to see. So I've gone ahead and I put a box, a green box around this first if, and then inside of that if, I've put a pink box around the nested if. So this pink part is actually inside of this outer green part. Okay. So what I want to happen is I don't even want to stay inside of this if. I don't want to go into this pink part. I want to actually wind up going down here. The only way that's going to happen is if this condition winds up being false. Because if this condition winds up being true, I'm going to wind up stuck in here and either medium or hot is going to be displayed. So I want this thing to be false. So how do how do I find out what makes that false? Well, basically, I want to take the opposite of this statement. This is checking to see if the number is greater than or equal to 10. So I know that I want my number to actually be the opposite. I want it to be less than 10. Because if my number is less than 10, this is going to be false. And I'm going to go down here to my else, and I'm going to display the message cold. So what I need to do is I need to look at my answer options up here and find a number that is less than 10. And hopefully there's only one. Yes, so there's only one option here that is less than 10. 10 is equal to 10. 15 is greater than 10, and 20 is greater than 10. So the fact that there's only one number that fits this statement tells me that I'm probably on the right track. And that's going to be the answer here. And if I scroll down, it actually says that that is the answer. And again, you know, all I really did here, and it might not be immediately obvious when you first start out, is I knew I wanted this to be false. Oops, I pressed the back button. I wanted this to be false, and so all I did was take the opposite of this statement. So number was less than 10. And so then I can go ahead and submit that guy. And it indeed says I'm correct. All right. So these types of questions are going to be really important for you to practice, especially when it comes to just getting used to the pseudocode. So if you want additional practice, you know, Khan Academy is there that I set up for you all. And also the AP Classroom has a number of practice questions as well that you can go through. So good luck. Bye, everyone.